Good morning, students. I'm going to start the class now, right? And today's class is in the beginning. We are continuing the system of particles and rotational motion. In that system of particles and rotational motion, for the rotating a body in the rotational motion, the force is replaced by with some word. What is that word? You write in the chat box. Is my board and my voice, is it clear or not? Yes, everybody give your attendance, and now I am continuing, right? And you listen very carefully. What I asked one question just now, just before this, I asked one question. That is, uh, what is the rotational analog of force? In the rotational motion, the force is replaced with a word. What is that? That is the torque, right? Very good, Anish Kumar. And now I'm going to continue. That is, now I'm going to start the topic, that is equilibrium. What is equilibrium in the physics? Equilibrium means what? Equilibrium means what? You listen very carefully. Till the end, everybody should present in the class. Okay, after giving the attendance, if you will leave, then it will be punishable for you. Okay, and actually, you are deceiving yourself. And don't do like that. I'm going to start the class. Right. Equilibrium means what? Equilibrium means under the forces, under the forces, if any object, under the forces, if any object or any body is at rest, under the forces, if any body is at rest, then that body is said to be in equilibrium. Then that body is said to be in equilibrium. This is the definition of equilibrium. When we say that one body is in equilibrium, under the forces, the body should be at rest. Okay, under the forces, if any body is at rest, then such body is said to be in equilibrium. These equilibriums are two types are there. First one is the translational equilibrium. When we say that the object is in the translational equilibrium, translational equilibrium means the body should not translate from one place to another place. Okay, translational equilibrium. The body should be at rest. Then for that, if net force on a body is zero, then that body is said to be in translational equilibrium. Okay, if net force on a body is zero, if net force on a body is equal to zero, then it is in translational equilibrium. To maintain a body in translational equilibrium, the condition is that the net force on the body must be equal to zero. Net force should be equal to zero. Okay, that means the force along the x-axis, force along the y-axis. Okay, summation of the all forces, summation of all forces is equal to 0. That is the net force, right? That means summation of forces along the x-axis equal to 0. Summation of forces along the y-axis equal to 0. Summation of forces along the z-axis is also equal to 0. In all the directions, the forces must be equal to 0. Then we say that that body is in equilibrium. Okay, I will give the example for this. For example, we are applying the forces like this. Okay, you see here, one force we are applying this side. This is F1, and one force we are applying force F2. and other force we are applying the F3. We are applying the three forces at here, right? And now under these three forces, right? If the object is at rest, if the object is at rest, then that object is said to be in equilibrium. That means the three forces they are acting at here, that three forces will cancel with each other and the net force become zero, right? In this case, we write the object is in equilibrium. Under the forces, the object should be at rest. Forces acts, but the object should be at rest. Then only we say that the object is in equilibrium, right? This is in translational equilibrium means net force should be zero, right? If the net force is zero, the object is said to be in translational equilibrium. Now, let us see here. We took the example of this one. This is F1 force, and this is F2 force, and this is F3 force. There are three forces acting on the object, and the algebraic sum of the forces is equal to zero. That means we write they are in the vector form. We have to write F1 bar plus F2 bar plus F3 bar should be equal to zero. Then that object is said to be in equilibrium. This is an object, then that is object we can consider as O, then we say that O is in equilibrium. O is in which equilibrium? Translational equilibrium. And translational equilibrium means it should not go from one place to another place. Then for the purpose, net force should be equal to zero. Then what about next type of equilibrium is the rotational equilibrium, right? Rotational equilibrium means object should not rotate. That means any type of motion it should not have. Then when we say that the rotational equilibrium, that means under the forces, the object should be at rest. Okay, it should not rotate. Okay, if net torque on an object is zero, then that is said to be if net torque zero, it cannot rotate. Okay, if net torque on a body is zero, if net torque on a body is equal to zero, right? If net torque on a body is equal to zero, then such body is said to be, then it is said to be in rotational equilibrium. If torque zero, it should not rotate. If force should zero, it should not move. Then if the torque on a body is equal to zero, then it is said to be in rotational equilibrium. Rotational equilibrium means it should not rotate. Under the torque, it should not rotate. Torque is the rotating force, right? Torque is the rotating force. Now it is said to be in rotational equilibrium, right? This is about translational and rotational equilibrium. If any object, okay, if any object is in translational and rotational equilibrium, then we say that net torque zero. Torque is denoted with a tau. Okay, if any object, if any object is in translational and rotational equilibrium, translational and rotational equilibrium, both type of equilibriums are there. If any object is in translational and rotational equilibrium, then it is said to be in equilibrium, right? Then it is said to be in equilibrium. When we say that object is in equilibrium, object should not move from one place to another place. Means translational should not occur, rotation should not occur. Then we say that the object is in equilibrium. The condition for the equilibrium is net force should be equal to zero, right? Then translational equilibrium, and net torque is also equal to zero. The rotational equilibrium. Then if the object not moves and not rotates, any type of motion is not there, then we say that the object is in equilibrium, right? If object is in translational and rotational equilibrium, then the object is said to be in equilibrium, right? I'm going to erase, you take the screenshot and note it. Till now is it clear? If any doubt is there, you write in the chat box, okay? And peer group leaders, you request other students to come to the class, okay? There is a huge loss. As a science student, if you are not attending the class, then in future you will be lost. That loss cannot be fulfilled in whole life also. That much loss will be there. You will cry in future. Okay, whenever you are enjoying it here means in future you will cry because you are living your duty and you are enjoying. right? Those who left their duty, they cannot enjoy in future, right? Let us see, and I'm going to continue. That is, if you have any doubt, you write in the comment box. Okay, the next topic is the principle of movements. What is the principle of movements? Principle of movements. Torque is also called as what? What is the another name of torque? What is the another name of torque? Can anyone give? Write in the chat box. What is the another name of torque? What is the another name of torque? Anyone? No one. Right. Next one is the principle of movements. The principle of movements is, if a lever, okay, if a lever, yes, baby Mato, good. It is the moment of force. Moment of force is the another name of torque. Torque is a rotating force, right? If a lever is in equilibrium, if a lever is in equilibrium, right? You know seesaw, seesaw, seesaw. Seesaw is a game in the parks you will see, right? And let us see here. This is just like a seesaw only we are giving, and this is a lever at here, okay? And this is a lever, okay? And it is the fulcrum, okay? The lever is suspended, it is fixed over the fulcrum, and this lever can rotate like this side and this side over the fulcrum. Okay, you will see the seesaw, right? And that is also same will be there, and on both sides seats will be there, right? The persons will sit on both sides, and if the weight on this side is more, right, then it will go like this, and its shape will become like this, right? He will go up, he will go down, right? If the weight is this is more, and this is the fulcrum, it will be rotate, right, like this based on the weight. Here the rotating forces are acting. Why the rotating force is acting? His weight is acting in downward direction at here, and this weight is a force, and here this is the fixed point at here, this is the perpendicular distance. That the torque is the formula. Torque formula is the force into perpendicular distance of the line of action of force from the fixed point. It is called as the torque, right? Now, like that, here the torque will act, rotating force will act. Do you know what is the name of this one? In the park you will observe. Can anyone write in the chat box? What is the name of that children will play in the park? Right, you see here, this is one load where hanging it here. This load we can consider as the load applying the force F1. F1 is the load, and here we are doing the effort, right? This is the effort, and I am applying the force at here to lift this load, right? And this distance is R1, and this distance is R2. Very simple, I am explaining, you listen it here, allow, right? And this is the one rod, just like rod, okay? It is fixed over the sharp edge, and this rod is able to rotate like this, okay? It can rotate like this. The rod maybe go like this, or the rod maybe go like this, right? This is the lever. And for example, if you want to lift the heavy load, right, you have to apply the force this side, then this will go up, right? And after that we can, when it goes up, then what happens, we can keep in certain trolley or somewhere, right, like this, by lifting. Then this lever is useful to lift the heavy objects very easily, okay? And it can, by applying the less force, we can lift the heavy loads at here. This is F1 is the load, one side load is there, okay? And other side I am applying the force F2. In this case, if this is in equilibrium, if this is in equilibrium, if lever is in equilibrium, there are two principles will come set here. That is the first principle is that first principle is the this is the liver is in equilibrium means it is in translational and rotational equilibrium, right? First it is in translational equilibrium. Translation first principle is that it should be in translational equilibrium, right? Liver is said to be in equilibrium, we are telling. That means it is this is the liver. Okay, this rod, it is over the fulcrum and it should not go down, not go up. That means downward force is equal to upward force. That means what we can write the first principle. First principle is that this lever is not in the linear motion. There are two forces acting in the downward direction, and this fulcrum applies the upward force. This is the fulcrum. You see, fulcrum. This fulcrum applies the upward force. By the weight, this will applies the force on the fulcrum. Fulcrum reversely applies the force. That is a normal reaction. Then normal reaction means action reaction will be there. For example, any object is on the surface. The surface applies the force on the object, that is weight, that is action. The surface also applies the force on the object, that is a reaction. We know that one, action reactions. This body applies the force on surface, that is action, downward direction. Surface applies the force on the body in upward direction, that is a reaction. Okay, right. Now what we know here, let us see here what we can write. The first principle is that translational equilibrium. What is the condition for the translational equilibrium, right? Can you tell the translational equilibrium condition? Net force should be equal to 0. What are the forces acting? N is the upward force, F1, F2 are the downward force. Means we write like this. First principle is that lever principle. Sum of upward forces is equal to sum of upward forces. Okay, is equal to the sum of upward forces is equal to the sum of downward forces. Sum of downward forces. Then it will be in equilibrium, right? It should not go in. It should not be in the translational. It should not be in translational motion. Okay, that force should be equal to 0. Sum of upward force equal to sum of downward forces. What are the upward forces in the figure? N. Okay, normal reaction. Downward forces F1 plus F2. Okay, right. Then from this we write sum of all forces equal to 0. Then it is in translational equilibrium. This is the first principle of the lever. There are two principles are there. Okay, what is the second principle of the lever? Second principle is that it should be in the rotational equilibrium. It should be in the rotational equilibrium. What this? There are two forces are there. Okay, and this force try to rotate this side anti-clockwise direction. This force F2 tries to rotate the lever in clockwise direction. But if it is in equilibrium, should not rotate in any direction. That means clockwise torque equal to anti-clockwise torque. Okay, sum of clockwise movements. Okay, sum of clockwise moment of forces means torque only. Sum of clockwise moment of forces is equal to the sum of anti-clockwise moment of forces. Sum of anti-clockwise moment of forces. Okay, right. Now, what are the clockwise moment of forces? Clockwise, this force F2 will try to rotate in clockwise, right? Clockwise torque, the torque which tries to rotate the object in the clockwise, and the torque which tries to rotate in anti-clockwise. If these two torques are equal, then it cannot rotate in clockwise, it cannot rotate in anti-clockwise. And what is the force? What is the torque formula in the clockwise? Can anyone write in the chart box? What is the clockwise torque formula? Force into perpendicular distance. What is the which force will make tries to rotate the lever in clockwise? F2, is it right? F2 will right to rotate. If F2 is more, it will go this side. It will go this side. You see the arrow mark. Here arrow mark will explain everything, right? This F2 force is used to rotate the in clockwise. That means this F2 torque required. Torque means force into perpendicular distance from the fixed point. Fixed point is the fulcrum, right? It is this lever is fixed over the fulcrum, right? It will be rotate about the fulcrum. Then the clockwise torque is what? Force into perpendicular distance of the force. What is that? No one is writing in the chat box. Okay, F2 R2. Then what is the anti-clockwise torque? That is F1 R1. This is the formula condition. Okay. In that the object will not rotate, lever will not rotate. What is F1 at here in this? F1 is the load. Okay. What is F2 here? Effort. Okay. Effort means we are pulling down. This is our effort to lift the load. And what is R1? R1 is the load distance from the fixed point. That's why it is said to be load arm. Load arm. Okay. And R2 is what? R2 is the effort distance. That's why it is said to be effort arm. Effort arm. Okay. Right. This is about lever. What is the use of the lever? By applying less force, you can lift the heavy object. By applying less force, you can lift the heavy object that you cannot lift with your direct hand without using the instrument. And what is the use of this one? Let us see. Is it clear till now? I'm going to erase this and you take the screenshot and note it. Okay. Okay. Next one is the mechanical advantage. In this mechanical advantage is there. Mechanical advantage of lever. Okay, what is the mechanical advantage in the lever? Right? What is the mechanical advantage? Mechanical advantage also has a definition. That is, it is the ratio between load and effort. Ratio between ratio between load and effort. Ratio between the load and effort is called as mechanical advantage. This is the formula for the mechanical advantage. Okay. If you have the doubt, you can ask. Okay, if it is clear, you at least type the clear. Okay, no doubt, sir. Now, what is the mechanical advantage? Mechanical advantage is that mechanical advantage formula is what? Load by efforts. Okay, load. F1 is the load, is it right? And effort is what? F2 is the effort. Load by effort, right? Now, mechanical advantage is equal to F1 by F2. F1 by F2. But this we can also write like this from the equilibrium concept. F1 R1 equal to F2 R2. From that we write as mechanical advantage F1 by F2 is equal to R2 by R1 we can write. If F1 is greater than F2 or if R2 is greater than R1, right? Then we say that the mechanical advantage is greater than 1. Okay, right. You see here, if you want to get the more mechanical advantage, what you have to do? Effort should be less. Mechanical advantage inversely proportional to effort. Effort should be less. Effort should be less means you should lift the heavy load. You should lift the heavy load by applying less amount of force. Okay, this is the fulcrum, and here this is the heavy load. Okay, F1 is the heavy, this heavy load you should by applying little force, okay, and you have to lift it. Effort should be less. Okay, we are applying the force at here. This effort should be less. The load should be high. Then high load we have to lift with the less force. Then we said that the advantage is there, right? Mechanical advantage is there. Load should be high than the effort. Then if load is high, okay, mechanical advantage is high. Load is effort is less, then mechanical advantage is more, because mechanical advantage and effort inversely proportional. This is less means this is more, right? If the effort is less effort, you are doing the less effort to lift the heavy load. That means advantage is more with the instrument, right? Further part we have to do, how to design that heavy load lift lever, and that to lift the heavy loads, we have to design the lever in such a way that its R2 should be greater than R1. Okay, R2 should be greater than R1. That means you should design like this. This should be more. You see this one here. This is R1. This is F1, and this is F2, and this is R2. You see, okay. If R2 is more than R1, R2 is greater than R1, the mechanical advantage is more, then easily you can lift the heavy loads by applying very little force. Okay, you have to design like this. Completed. And with this, our equilibrium concept is completed. Now I am going to continue. Right? Take the screenshot. Till now, is it clear? Equilibrium. Next topic is important, most important topic we are going to start. I am going to start. That is a moment of inertia. Right? What is the moment of inertia? Moment of inertia. What is moment of inertia? Moment of inertia denoted with capital I. Okay. What is moment of inertia? What is the definition of the moment of inertia? It is the rotational analog of mass is called as moment of inertia. Rotational, simple definition. Actually, one more definition is the actual definition. There is a rotational analog of mass. Rotational analog of mass is called as moment of inertia. Moment of inertia. It is a rotational analog, right? Now, rotational analog of mass means what? Actually, in the every term we are replacing with some other term in the rotational motion. The mass in the linear motion is replaced with the moment of inertia in the rotational motion. You see, this is linear motion. In the linear motion, force is there, that is replaced with the torque. Displacement is replaced with the angular displacement. Velocity replaced with the angular velocity in the rotational motion, right? And acceleration replaced with angular acceleration. Like this, every term, momentum is replaced with the angular momentum. Okay, force is replaced with here torque. Like this, in the rotational motion, mass is replaced with the moment of inertia. Instead of mass, we are using the moment of inertia. The class. Rotational analog of mass is called as moment of inertia. Okay, that means instead of mass, we are using the word that is the moment of inertia in the rotational motion. Okay, right. Now, uh, what is the formula for the moment of inertia? Okay, what is the formula for the moment of inertia? What is the need to define the moment of inertia? You listen very carefully. Okay, and now definition of moment of inertia. I will give the definition of moment of inertia. Before that, I will explain that this is a axis of rotation. This is the axis of rotation. Axis of rotation. Around this, one object is rotating. This is an object which is rotating around this axis, and this object has many particles, and that particles are masses m1, and one is m2, and other one is mn, and these particles having the perpendicular distances from the axis of rotation r1 and r2 and rn. Okay, then how to write the moment of inertia formula? Moment of inertia formula is we write as m1 r1 square plus m2 r2 square and so on mn rn square we can write. This is the formula for the moment of inertia. This we can also write in the summation form, that is I is equal to summation mi ri square. One minute. Class disturb हो गया। फिर अभी क्या करेंगे? Okay, listen it here. Now, this is the moment of inertia formula. Moment of inertia formula is we write summation mi ri square we can write. This is a very important formula. What is the moment of inertia? What are m1, m2, mn and so on? This one m1 comma m2 and so on mn are the masses of particles. What they are? Masses of particles. Okay, and r1, r2, rn are what? R1, R2 and so on Rn are the perpendicular distance of particles. Perpendicular distances of particles. Perpendicular distance of particles from axis of rotation. From axis of rotation. Okay. Right. This you see here once again I will explain. This is an object. Its total mass we can consider as capital M. This object is rotating around the axis. Okay. And this object has many particles whose mass are m1, m2 and so on mn, and their perpendicular distances are r1 and r2 and so on rn. So, a perpendicular distance means this distance is making 90 degree with the axis. Okay, and now this is what m1 r1 square, product of mass of particle and square of perpendicular distance. Product of mass of particle and square of perpendicular distance. This is what mass of particle. R1 square is what? Square of perpendicular distance. This is the product. Product of mass of particle and square of perpendicular distance. Then such products m1 r1 square, m2 r2 square, mn rn square, all are the products. Their product sum is called as the moment of inertia. That is the definition of moment of inertia. Definition of moment of inertia is definition of moment of inertia is sum of products of masses of particles, sum of products of mass of particles, and sum of mass of particles, sorry, sum of products of mass of particles and squares of squares of their relative their relative perpendicular distances from axis of rotation is called as moment of inertia. That is called as the moment of inertia. Moment of inertia formula is what? m1 r1 square plus m2 r2 square and so on mn rn square. I will explain once again. Okay, what is m1 r1 square? It is a product. Product of what? Mass of particle and square of perpendicular distance from axis of rotation. It is a product of m1 and r1 square. m1 is what? Mass of particle. r1 square is what? Square of perpendicular distance of particle from axis of rotation. Right? m2 r2 square is what? Mass of particle and square of perpendicular distance of particle from axis of rotation. Like this is a product, this is a product, this is a product, and that product's sum is called as the moment of inertia. That sum of products of mass of particles and squares of their relative perpendicular distances is called as, okay, from the axis of rotation is called as the moment of inertia. Then what is the SI unit of the moment of inertia? SI unit of moment of inertia. SI unit of moment of inertia is mass into square of distance, kg meter square. Mass unit is kg and R unit is a distance. R is a distance, meter square we can write. Now, moment of inertia, it is a scalar. Remember it. It's not a vector. It is a scalar. Okay, it is a scalar quantity. Scalar means what? It does not have any direction. Okay, and moment of inertia dimension formula is what? Can anyone tell the dimension formula of moment of inertia? Dimensional formula. Dimensional formula is what? Mass into square of distance. Mass is what? M. Square of distance is what? Distance is R. R is L. R will come in the length. M L square is the dimensional formula. Okay. And what I am telling it here, the moment of inertia, Alok, right? Listen carefully. Moment of inertia definition. What is moment of inertia? I am telling. In the linear motion, there are some terms are there. In the rotational motion, the terms will be changed into other terms. Then in the linear motion, the mass will be there. In the rotational motion, the mass is replaced with another term, that is inertia. Then the moment of inertia definition is what? Moment of inertia is what? Okay, rotational analog of mass means rotational motion में मास को दूसरा टर्म से रिप्लेस करता है, उसको मोमेंट ऑफ इनर्शिया बोलता है. मास को लिनियर मोशन में यूज करता है, उसको रोटेशनल मोशन में दूसरा शब्द यूज करता है, उसको बोलते हैं मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया का डेफिनेशन क्या होता है? रोटेशनल मोशन में यूज करता है, इसलिए एक ऑब्जेक्ट ले रहा है मैंने, उस ऑब्जेक्ट एक एक्सिस अराउंड एक्सिस रोटेट कर रहा है, राइट? देन उस ऑब्जेक्ट, every object is made up of many particles, m1 m2 mn, like this n particles are there. Then first particle distance from axis of rotation is r1, second particle distance is r2, nth particle distance is rn. Now here the moment of inertia definition is, it's a basic formula, its derivation is not there. Moment of inertia is basic formula, just like velocity is equal to displacement by time. Okay, and for that there is no derivation for that, it is a basic formula. Okay, and here I is equal to m1 r1 square plus m2 r2 square and so on mn r square rn square is the formula for the moment of inertia. Based on this formula you should write the definition. Then how to write the definition? m1 r1 square is what? Tell me. m1 r1 square is what? Product of what and what? Mass of particle and square of distance. m2 r2 square is what? Mass of product, it is also product of m2 and r2 square, product of mass and square of perpendicular distance. mn rn square is what? Mass of particle, rn square means square of perpendicular distance. This is a product, this is a product, this is a product. This product's sum is called as a moment of inertia. Then sum of products of what and what? Sum of products, this is a product, this is a product, this is a product. Their product sum is called as moment of inertia. Sum of products is called as a moment of inertia. Products of what and what? Products of mass of particles. Okay, M1, M2, and so on. M1 are the mass of particles, and R1, R2, Rn are what? Square of their relative perpendicular distances. Product of mass of particles and square of their relative perpendicular distances. The sum of that all things, sum of the products is called as a moment of inertia. Product means into M1 into R1 square is a product. M2 into R2 square is a product. Mn into Rn square is a product, because it is we are getting by multiplying Mn and Rn square. These products sum is called as moment of inertia. Sum of products is called as moment of inertia. Products of what and what? Products of masses and squares of their perpendicular distances. Have you understood, Alok, now? Is it clear? Is it clear? Okay, I'm going to erase this. Now, on what factors the moment of inertia depends? Moment of inertia depends upon some factors. What are they? Okay, moment of inertia depends upon some factors. First point is that moment of inertia depends upon position of axis. Position of axis of rotation. Position of axis of rotation. Okay. Why? Why it will depends upon the position of axis of rotation, and it is also depends upon the mass of body, and it's also depends upon the distribution of particles in body. Okay, and it is also depends upon the shape and size of body. Shape and size of body. And next, fourth point is the distribution of particles in body. These are the factors on which the moment of inertia depends. Right? You see here, this is the axis, and if the object is at long distance from the axis, it is rotating around the axis like this. At that moment, what happens? The distance will be increases, then moment of inertia increases, because moment of inertia is the sum of products of mass of particles and squares of their relative perpendicular distances. R1, R2, Rn will be increases when axis is at long distance. If you take this axis, about first axis, about second axis, one object has many moment of inertias about different axes. About this axis, about second axis, moment of inertia is less, because distances are less. Object distance, this object distance are less. But if you take this axis, then the object distances are more. That's where moment of inertia is more. That means one body has different moment of inertias about different axes. Right? Single object has different moment of inertias about different axes. That means when the axis changes, the moment of inertia is also changes. Okay, have you understood? Same object, same object, single object has different moment of inertias, different moment of inertias, different moment of inertias about different axis of rotation. Okay, different axis of rotation. Next one, what is the importance of this moment of inertia? What is the need to define this? Importance of moment of inertia. Importance of moment of inertia. What is the need to define it? And what is the need of this moment of inertia? What it will explains? What is its importance? The importance of moment of inertia is right. It is the it is the resistance. It is the resistance for the change in the resistance for the change in rotational motion. Rotational motion. Okay. Mass is the measure of inertia. Do you know inertia is measured by the mass? You know that one in the laws of motion we discussed. Mass is the measure of inertia. Mass is the measure of inertia. And moment of inertia is the measure of rotational inertia. Do you know what is the meaning of inertia? What is this? What I am writing it here? If moment of inertia is more, okay, then rotational inertia is also more. Rotational inertia is what? If moment of inertia is less, can anyone give the definition of inertia? Moment of inertia is less, then the rotational inertia is also less. What is inertia actually? Inertia क्या होता है? It is the resistance for the change in rotational motion. That means, for example, inertia means every body continuous in its state of rest or uniform motion. Every body continues in its state of rest or uniform motion unless it is acted upon by external force. कोई भी ऑब्जेक्ट सेम स्टेट में कंटिन्यू करना को इनर्शिया बोलता है. मतलब आप बहुत स्पीड से रनिंग कर रहा है, जल्दी आप रेस्ट में नहीं आ सकते हैं. बहुत स्पीड से एक डायरेक्शन में जा रहा है, जल्दी आप उस डायरेक्शन छोड़ के दूसरे डायरेक्शन में टर्न नहीं कर सकते. दैट मीन्स सडनली स्टेट को चेंज करना पॉसिबल नहीं होता है. मतलब कोई भी ऑब्जेक्ट अपना स्टेट में रन मोशन स्टेट में और नहीं तो रेस्ट में हो तो रेस्ट स्टेट में सेम स्टेट में कंटिन्यू करने के लिए कोशिश करता है, उसको इनर्शिया बोलता है. ये रोटेशनल इनर्शिया क्या होता है? रोटेशनल इनर्शिया मतलब रोटेटिंग बॉडी रोटेटिंग में कंटिन्यू करने के लिए इच्छा होता है. मतलब रोटेटिंग बॉडी रोटेशन स्टेट से रेस्ट में नहीं आता है, राइट. रेस्ट वाला रेस्ट में कंटिन्यू करने के लिए ट्राई करता है, रोटेशनल मोशन वाला रोटेशनल मोशन में कंटिन्यू करने के लिए ट्राई करता है, उसको हम लोग रोटेशनल इनर्शिया बोलते हैं. रोटेशनल इनर्शिया इज द ओके it is the inability of a body to change in its state of rotational motion. That means it will not allow to change its rotational motion. It will continue in the rotational motion. That means if inertia is more, it will rotate for more time after switch off the motor also. Okay. If inertia is less, then it will stop very soon. Right. For example, you are rotating a wheel. Okay. Once you apply the torque and it will rotate. And if inertia is more, then it will take long time. Okay. It will take long time to come back to the rest. It will rotate for more time. Okay. It will rotate for more time. For example, the wheel, for example, cycle wheel is very large size. If the cycle wheel is very large size and they are using the spokes, most of then at the moment most of the particles are at the rim of the wheel. Then the moment of inertia about this axis it will rotates. These are the distances r like this. Then the moment of inertia is what? M1 r1 square, M2 r2 square, and so on mn rn square. This M1 here, M2 here, M3 here, r1, r2, r3 like this. Then here all the particles have the same mass and same distance. Then we write as moment of inertia, we write as I equal to some summation of mr square we write. Okay, or capital mr square we write. That means what happening at here, r is more means the moment of inertia is more. If moment of inertia is more, then once you rotate the wheel, then it can rotate for a long time. Immediately it will not come to rest, because if r is more, then the moment of inertia is more. Moment of inertia is more means rotational inertia is more. Rotational inertia is more means the body which is in rotational motion, it will try to continue in the rotational motion. It will not immediately come to rest. If you have the doubt, you can write in the chat box. I will not worry with your questions. Okay, I will try to answer for your questions. You try to ask questions if you get the doubts. Okay, this is completed. And the next topic I am going to start. That is the radius of gyration. What is the radius of gyration? Next topic is the radius of gyration. What is the radius of gyration? Radius of gyration is denoted with K. Its definition is root mean square value of perpendicular distance of all particles from axis of rotation. This is the root mean square value. Root mean square value of perpendicular distance of all particles, perpendicular distance of all particles from axis of axis of rotation is called as radius of gyration. Radius of gyration. Then you see this figure. This is the axis of rotation, and this is an object. This object has so many particles. Their distance are m1 particle distance is r1, m2 particle distance is r2, m3 particle distance is r3, mn particle distance is we can consider as rn. Like this, okay, the many particles are rotating around this axis. Object is rotating around the axis. Then what is the root mean square value of perpendicular distance of all particles? R1, R2 and so on, Rn are the perpendicular distance of particles. Root mean square value means, here we write like this, R1 square, R2 square. I will explain with the explanation I am. What we are telling it here, root mean square value of perpendicular distance of particles. You should follow the cursor. Root mean square value of perpendicular distance of all particles. First, perpendicular distance of all particles is what? R1, R1, R2, R3, Rn. What are they? They are the perpendicular distance of particles. Okay, and perpendicular distance squares of square value of perpendicular distance of particles. Square you can find out. For the perpendicular distances, squares you can find out. This is the squares of perpendicular distance of particles. Their mean you can find out. First perpendicular distances, next square root, next mean. Mean means the sum of quantities by number of quantities. Sum of quantities by number of quantities. Add them, divide with the number of quantities. This is mean. For this, you can keep the root. This is called as the radius of gyration. This is the formula for the radius of gyration. Okay, right. This radius of gyration SI unit is a distance. So its SI unit is meter. Okay, its SI unit is meter. Now next, the dimension formula. It is just length only. Dimension formula we write as L. Okay, and if you know the radius of gyration and total mass of body, if capital M is the capital M is the mass of body, not mass of particles. Capital M is the mass of body, and K is its radius of gyration. A is its radius of gyration. Then moment of inertia we write like this. K formula another one is there. That is a moment of inertia formula in terms of mass of body and radius of gyration is I equal to mk square. Okay, m is the mass of body, means sum of mass of all particles. Okay, and radius of k we can also write from this k radius of gyration under root I by m, under root I by m. Okay, and more 10 minutes I will continue the class. Okay, and I will write the some table that you will get one more question from that table. Any one formula you will get in the exam. One table I will give which shows that moment of inertia of different objects. Okay, right, let us start. Somewhat difficult to draw the table now. Okay, you see here this is the serial number. This is the axis, and this is the figure. This is the moment of inertia formula, and this is the radius of gyration. Okay, let us start. First, just you have to remember any one formula they will ask in the exam. First, I am going to write the object, that is the ring. Okay, and that is the object is ring. Okay, one more. One more column is required. Okay, let us start. First one is the ring. Ring, first axis is about an axis passing through center and perpendicular to plane. Perpendicular to plane. Right. This is a ring. Okay. You see here. This is a ring. And this is an axis. Axis is this one. Axis is passing through center and perpendicular to plane. This is the axis. Okay. About this axis, I want the moment of inertia. Right. And for this, you remember the moment of inertia formula is the radius is considered as capital R, and the mass of the ring we can consider as capital M. And then this is an axis passing to center and perpendicular to plane. About that axis, the moment of inertia formula is mr square. Can you write the radius of gyration formula? Just it is very simple. Radius of gyration is under root I by m. In this I you substitute mr square by m, or otherwise I is replaced with mk square. Mk square equal to mr square. K is equal to r you will get if you will simplify this. This is the first one. And the second one is the same ring only, but about diameter I want. Same ring, but about diameter. Okay. About diameter, moment of inertia what? Diameter is the axis now. Okay. This is the ring, and the diameter how it will be there? This is the diameter. Okay, you see here. This is the diameter, and around the diameter it is rotating. About the diameter it is rotating. Then what is the formula for the moment of inertia? Moment of inertia formula. Just you have to by heart the moment of inertia for of formulas. Mr square by 2 you will get. Okay. And the what about the radius of gyration? Can you find radius of gyration? Can you write in the chart box what is the radius of gyration? Next one is the disk. The disk, what is the formula? Disk about an axis, about an axis, about an axis passing through center and perpendicular to plane. Then what is the formula for the moment of inertia? Okay, you see here we are taking the disk now. What is the difference between the disk and ring? Disk is the, you see here the disk means just like 1 rupee coin. 1 rupee coin you can take as a disk. It has a matter at the center also. Now this is the disk. And now this axis is passing the center and perpendicular to plane. About this axis, what is the formula for the moment of inertia? Right? Its mass is m and the radius is r. Then the moment of inertia is what? Then the moment of inertia about this axis we find out. About this axis, you know. Now about this axis I want to find out for the disk. Then just you have to by heart it. Right? That is mr square by 2. Okay. And now you will get the k is r by root 2. Here also you will get as r by root 2. And the next one is about diameter I want. About diameter. About diameter it is rotating. This is the disk. And now the axis is the diameter. This is the axis. Around the axis it is rotating. About the axis. Moment of inertia formula is what? The moment of inertia formula is mr square by 4. mr square by 4. The k formula you will get is r by 2. Okay, actually you need to by heart only I formulas, not k. K formula directly you will get, because I formula you write mk square equal to I formula mk square, I formula mk square, I formula mk square you substitute. Then from that you will get the k formula, right? Just you have to by heart the moment of inertia formulas about which axis it is, that you have to by heart. I'm going to erase this. Two objects we discussed the moment of inertia. More 3 4 I will give, and then I will close today's lecture. Next, third one. Third one is the rod. Okay, thin uniform rod. Thin uniform rod. Then what about the thin uniform rod axis? Axis is passing through center, and about an axis passing through center and perpendicular to its length, and perpendicular to its length. There is a perpendicular symbol I drawn. Okay, and the diagram will be like this. This is the rod. Okay, and the rod length we can take as L. Rod length we will take as L, and this rod moment of inertia about an axis passing to center and perpendicular to its length. This is the axis now. Okay, axis is passing through center and perpendicular to its length. About this axis, I want the moment of inertia, right? And now the moment of inertia formula is, you remember it. It is ml square by 12. Ml square by 12. Okay, right. Next one, the same rod about an axis, or the same rod about an axis passing through one end of the rod, passing through one end of rod. What is its moment of inertia? This here the same thing. This is the rod. Rod mass is m, and the rod length is L. But here we want the moment of inertia about an axis. That axis passing through one end, like this. About this axis, I want the moment of inertia, right? The moment of inertia formula, you remember it as ml square by 3. What is m in this? M is the mass of rod. Okay, m is the mass of rod. What is L in this? L is the length of the rod. L is the length of rod. Okay, right. From this you find the radius of gyration also. Here we have tried the radius of gyration. K is equal to how much you will get. You find out yourself. Okay. Here you will get, I think, L by, what you will get, L by root 12 you will get. Here you will get L by root 3. Next, one more object I am going to give. That is the solid sphere. Solid sphere. Solid sphere about any diameter I want. About any diameter. Solid sphere. Do you know the different ring we discussed? Disk we discussed. Next, sphere. Solid sphere means inside also matter is there. Its moment of inertia formula is 2 by 5 mr square. 2 by 5 mr square. K you will get is root 2 by 5 r. Next, hollow sphere. What is the difference between the solid sphere and hollow sphere? You know, solid sphere means inside also matter is there. Hollow sphere means just like a ball, volleyball like that. Okay, in that hollow sphere means inside matter is not there. About this axis, moment of inertia I want. Moment of inertia formula is 2 by 3 mr square. Its radius of gyration formula is under root 2 by 3 into r. Okay, last I am going to give hollow cylinder and solid cylinder. Then I will close. I am going to erase this. Next one is the hollow cylinder. Is it six number? I forgot. Hollow cylinder. What is a hollow cylinder? About its geometrical axis, I want. About geometrical axis. Okay, this is the geometrical axis. This is a hollow cylinder. Geometrical axis is this one. About this axis, I want the moment of inertia for the hollow cylinder. If you will cut the hollow cylinder, what you will get? For example, this is a hollow cylinder. If you will cut like this, you will get the rings. Okay, ring moment of inertia formula we have to write it here. Very simple. What is the ring moment of inertia? Basic formula mr square we write. Okay, and k is you will get as r. Next, last one, solid cylinder. You by heart all the you by heart this table. Any one question you will get for the 1 mark. Either write for the moment of inertia of anything. Just you have to by heart the formulas of moment of inertia about its geometrical axis. What is geometrical axis for the solid cylinder? This is the solid cylinder, right? And this is the geometrical axis. Okay, so if you cut the solid cylinder, you will get the disk. Solid cylinder, if you will cut, you will get the disk. What is solid cylinder? Solid cylinder means just like this only there. Okay, but you have inside also matter is there. Inside also matter is there. If you will cut this solid cylinder, then what you will get? Disk you will get disk like this. About the disk, about an axis passing the center and perpendicular to plane. Moment of inertia is what? About this axis. We know that. For the disk, about this axis we know. mr square by 2. That means solid cylinder is moment of inertia is similar to the disk moment of inertia. Hollow cylinder moment of inertia equal to the ring moment of inertia. Because if you will cut the hollow cylinder, you will get the if you will cut the hollow cylinder, you will get rings. If you will cut the solid cylinder, you will get the discs. Okay. Right. Thank you to all. And today's lecture is closed. More 2-3 periods required to complete this chapter. Okay. And tomorrow also class there. Every day I will take the class. Okay. Except holidays. And you try to cooperate and join in any time. Okay. I will give the time. Tomorrow also class will be there.